Hello everyone! In this video we're going to learn how to enlarge or reduce a 2D shape by a given scale factor. We're going to find out what a scale factor is, which is similar to proportions, and we're also going to work out what this scale factor might be if a shape was enlarged or reduced. Here are two proportionate to each other right-angled triangles. So a little one and a larger one. Write the ratio of side A to side B. I will explain to you what a ratio is in a little bit. Let's compare these triangles first. Let's have a look. How many times larger is this triangle than this triangle? Well, how long is this side first of all? Count how many squares. 1, 2, 3, 4. 4 centimeters long. Okay, now let's see how long this side is. We've got 4, 8, 12. 12 centimeters long. Okay. How many times larger is 12 than 4? 12 divided by 4 is 3. So this side is 3 times larger than this side. Don't confuse it with the difference between. We're not taking away, we are dividing. We're seeing how many times this side is larger than this side. Now, how long is this side? Okay, I can see two squares, 2 centimeters long. And how long is this side? 2, 4, 6. 6 centimeters long. So how many times larger is 6 than 2? Well, I know that 6 divided by 2 is 3. So that means that this side is 3 times larger than this side. Do you remember about this and this side? They were also 3 times larger. So we can presume that side B will be 3 times larger than side A. And the way you write it down is like this. Now let me get a different color felt tip. So you write it down like this: 1, 2, 3, and this is the proportion. So for 1 square, let me show you how it works. Oh my goodness, my camera is falling down. Right, for 1 square on this triangle, can you see 1 square? You get 3 squares on this triangle. Another square, you get another 3 squares. Another square, and then you get 3 more squares, and the last square, 3 more squares. Can you see? So this is what proportions are for each square on this triangle. You get 3 squares on this triangle. Yeah, let's see if it works the same with this side. For each square on this triangle, you get 3 squares on this triangle. 1, 2, 3. For each square, you get 3 squares. So this is what it means. 1, 2, 3. Yeah. For each square on here, you get 3 squares on this side. Proportions sometimes could be a little bit different. Let's imagine, have you ever seen proportions like this? 2 to 3. So I'm going to draw a new triangle now, which is proportionate to this original triangle, and proportions are 2 to 3. So my proportions are 2 to 3. So I'll have 2 squares here. Look, 2 squares. For every 2 squares, I'm going to have 3 squares on this side. So that's 2 squares. And on this side, I'm going to draw 3 squares instead. Can you see? 3. Okay, then I have another 2 squares. And on my enlarged triangle, I'll draw 3 squares instead, like that. Okay, now this side. Remember, for every 2 squares, I get 3 instead. So I have 3 squares here. 2 squares here. So I'll have 3 squares on this side. Yeah? And then I'll just have to join the lines together. So the proportions of this triangle now and this triangle are 2 to 3. Because for each 2 squares on this triangle, you get 3 squares on this triangle. Can you see? Right. Okay, second question is enlarge shape C. This is shape C by the scale factor of 3. What it means is that you need to enlarge this triangle by 3 times. So everything needs to be enlarged by 3 times, not just 3 squares added on to the sides. That's what quite often children do, but you have to times each side by 3. So how many squares is this side? 2 squares. So we need to times it by 3. 2 times 3 is 6. So now it's going to be 6 squares. How long is this side? 3 centimeters, so 3 squares. We need to times it by 3. 3 times 3 is 9. So 1, 2, 3 goes all that way. You'll have to use a ruler, obviously. I'm just showing you without a ruler, which I'm being a bit naughty. And you just join these 2 leftover points. So what you've done, you've enlarged shape C by scale factor 3. So you multiplied each side by 3 and you drew a new shape.